Hello class, in this lesson we're going to be looking at the different types of scales. First of all, let's remember that there are 5 important properties of measurement scales. The first one is distinctiveness. This means that different numbers are assigned to persons with different values of the attribute that we're measuring. The second thing is order of magnitude. That means that we give larger numbers to larger amounts of the attribute that we're measuring and lower to the lower quantities. Now, if the scale also has equal differences between different ability levels and they are indicated by numbers that go in a progressive order, the measure also has equal intervals. And finally, if there is a 0 point that indicates the absolute absence of the attribute, the measure also has an absolute 0 point. Now we're going to see different kinds of measurement scales, and each of them have one or several of these different characteristics. The first kind of scale is the nominal scale. Now in this one, arbitrary numbers are used to name or represent different classes or categories that are given of an attribute. Okay, so these numbers do not indicate value, they just identify the categories. And of course, these are used to collect demographic information from test takers, which can at a subsequent time be analyzed to estimate some kind of bias against specific groups of people, or just to compare the performance of different groups of people, like differences in ages, gender, place of origin, and so on and so forth. Here we have some example of nominal scales. We assign this number to the student to identify her in a specific test. We also take some information from the date of birth in order to be able to compare the performance of particular age groups. There's also the country code, right, and the native language code. These numbers were assigned in a random way. That means that it could be 300 or 500 or 1000 or 3 or 5. We're just using those numbers to represent those values, okay? But it doesn't mean that if Japanese has 300 and Spanish has 200, that Japanese is more important because it has 300 and not 200. Okay, the numbers are arbitrary, they don't represent a value. A special case of a nominal scale is the dichotomous scale. It's called dichotomous because there are only 2 categories of the attribute. For example, number 1 male, number 2 female. So in this case, we're saying that writing number 1 indicates that the person is a male, writing number 2 indicates that the person is a female, but it doesn't mean that because male is number 1 is less important than female because female has 2. 2 is more than 1. That is not the case. We're only saying that number 1 represents a male, number 2 represents a female, and it could be the opposite. Male could be 2 and female could be 1. We're just deciding which number represents which attribute. Another important example is the dichotomous scale that is used on objective tests. Number 1 represents a correct answer, number 0 represents an incorrect answer. This is very important when we analyze the results of our objective tests. Here is one example. We gave a test to 20 students here, and there are 10 questions in total. So every number 1 that you see on the spreadsheet represents a correct answer, and every 0 that you see on the spreadsheet corresponds to an incorrect answer. So we can see, for example, that student number 1 got 1, 2, 3, 4, 5, 6 correct answers. Okay, so entering the information in this way is going to allow us to later analyze the information and calculate things such as the facility and the discrimination indices of a test. Another kind of scale is the Ordinal scale. Now, an Ordinal scale comprises the numbering of different levels of the attribute that are ordered with respect to each other. And very obvious examples are the rankings or the scoring rubrics. In this case, the points or levels that are indicated on our Ordinal scale can be characterized as greater than or less than. Ordinal scales are very important for the design of scoring rubrics for a subjective test. Here is one example. This is a scoring rubric for academic texts. We can see that there are different categories: task compliance, topic development, organization, vocabulary, discourse control, sentence structures, and mechanics. And each of these is represented by a different description of the quality of the paper, whereas the lowest value, number 5, indicates a very low level of the attribute. Let's look at the example of task compliance. Does not address the writing assignment of topic throughout the writing. So we have descriptions that represent different levels of the category, and we're going to assign these different levels of performance to different kinds of text written by the students. Another kind of scale is the interval scale. And the interval scale is different because in this case there is a numbering of the different levels, but in this case the distances or intervals between the levels are equal. That's what we call equal intervals. We're going to see an example on the next slide, but now we're going to look at another scale, which is the ratio scale. In a ratio scale, we have a true 0 point. Okay, so this means that we start from 0, from the absence of the characteristic that we're measuring, and then every subsequent measure represents or is represented by multiples of a predetermined value. We normally use this in the exact sciences, okay, to measure physical phenomena such as length or temperature or weight, but it's not very common in the humanities. Why? Because sometimes it is difficult to find the absence of a human quality. Okay, there is always a little bit of all of the qualities. Now this is an example of a comparison between the interval scale and the ordinal scale. On the right we have a ranking, which is of course an ordinal scale. In this case, we're going to see who got the best results in the test. So the first person is the person who has the highest score. The second person is the person with the second highest score, and so on. So we order them in a ranking: the best student, the second best student, the third best student, and so on and so forth until the worst student. Okay, this is just a ranking. It's an ordinal scale. Now on the other side we have the test scores, which are represented by the number of correct answers. So in this case we have an interval scale, and we can see how the ordinal scale does not really care about the true values of the test score, which is represented by an interval scale. So we can see between the first and the second students there are only 5 points, but between the second and the third there are 10 points, and then again from the third student to the fourth students there are only 3 points. But it doesn't matter. This student who got 80 points is the third place, and the student who got 77 points is forcibly number 4. Okay, even though there are just 3 points, any point makes a difference, but we can see here the distinction between. So Those are the different types of scales, and I want you to review this information because when we are going to be designing tests and assessment instruments, we're going to be using almost all of these types of scales. Okay, so good luck with your task and see you next time.